All right, today we're jumping into something pretty wild. It's a bold new blueprint for physics coming out of Vietnam that claims it's found a way to unify all the seemingly disconnected laws of the universe. And get this, it's not just another theory, it's an entirely new rulebook for how to do physics. So let's get into it.
So first off, why do we even need this? What's the big problem we're trying to solve? Well, if you look at modern physics, it's kind of a mess, a zoo, really. We have one set of laws for giant things like stars and galaxies, and a completely separate, totally different set of laws for the quantum world of tiny particles. It feels like we have a dozen different instruction manuals for what should be the exact same machine.
But what if all those different manuals are really just bad translations of one single master document? That's the incredibly bold claim of something called the Unified Postmodern Theory, or UPT. Now, that word postmodern might sound a little strange for physics, right? But all it really means here is moving past our modern, broken-up view of everything. The whole idea is that the divisions we see in physics, they aren't real. They're just illusions created by how we've been looking at things. To really get what they're proposing, we first need to appreciate just how deep this problem of fragmentation goes.
I mean, just think about this lineup. You've got general relativity running the show for gravity. You have quantum mechanics doing its own bizarre thing at the smallest scales. Then there's electromagnetism, thermodynamics, fluid dynamics. I mean, the list goes on. Each one of these is a total powerhouse in its own field, incredibly successful. But they don't talk to each other. They don't speak the same language. It's like a bunch of isolated islands of genius.
And this isn't some new problem. For the better part of a century, the absolute holy grail of physics, a dream people like Einstein obsessed over, was finding that one single elegant theory that ties it all together. That's the epic quest that sets the stage for what UPT is trying to do. So, how in the world does UPT propose to finally achieve this dream of unification? Well, it's not just about a new equation. It's about giving us a whole new blueprint, a new way to see how anything in the universe interacts with anything else. Okay, so here's the core claim, and it is a huge one. The UPT says that all the different forces and fields we see aren't actually different, not fundamentally. The theory argues they're all just one underlying reality, but we're seeing it through 4 different distorting lenses that are built right into how we do science. And here they are, the 4 lenses. First, we have our local viewpoint, where we tend to only look at what's happening right here, right now. Second is our love of the linear shortcut. We simplify messy, complex reality into nice, easy straight lines. Third, there's a massive language barrier. Different fields of physics literally have different names for the exact same thing happening at the edge of an object. And finally, we ignore the hidden scales. We don't do a great job connecting the tiny, microscopic details to the big picture. UPT's claim is that if you can just correct for these 4 biases, the unity of physics just pops into view. So if we manage to take off those distorting glasses, what's left? Well, according to UPT, what's left is a single, universal description for all interactions, and it's all captured in one master formula. Now, before we even look at the formula, you have to get your head around this one crucial concept. The UPT framework divides everything into just 2 parts: the bulk, which is the inside of a thing where energy is stored, and the boundary, which is its surface. And here's the really wild part. The UPT says the boundary is the only place anything actually happens. That's where all the work gets done, where all the energy gets exchanged. The inside is just storage. The surface is where all the action is. And that idea is summed up right here in their main energy principle. Now, don't worry about all the symbols. The really important part is that second chunk, the one that deals with the boundary. What this says is that the total energy of anything is just the energy it has stored up on the inside plus the energy that's available right there on its surface. And again, the key takeaway is that all the interesting stuff, all the energy moving around, it only happens at that boundary. This all leads to the master formula itself. It calculates something the theory calls traction. You can basically think of it as the sum total of all the pushes and pulls happening on any single point on an object's surface. Think of this formula as a kind of universal recipe, a Rosetta Stone for figuring out forces, no matter if you're talking about fluid dynamics, solid mechanics, or electromagnetism. And every ingredient in this recipe has a clear job. That first term, that's the pushback from what's going on inside the material.
The second one is like the friction or resistance right at the surface. The third piece is the direct push or pull from any outside forces or fields. And that last one, that captures any twisting or stretching happening along the surface. UPT says that any interaction you can think of is just some combination of these four basic ingredients.
Okay, so having a universal language is great, but you also need a grammar book, right? You need rules to make sure everybody's speaking it correctly. And that's where UPT's Code of Practice comes into play. This framework doesn't just throw ideas out there. It comes with 12 strict operational rules. And these aren't just random rules. They have very clear goals. To make sure everyone reports their results the same way, to let us compare different models directly, to force every model to prove it conserves energy, and to finally get everyone using the same words for the same things. One of the biggest challenges this new rulebook tries to solve is a real classic headache in physics, the scale problem. How do all the tiny details at the microscopic level actually add up to create the solid, macroscopic world we all live in? To solve this, the UPT offers a very specific procedure called multi-scale homogenization. It sounds fancy, but it's a pretty logical three-step process. First, you take a tiny, representative sample of whatever you're studying. Then you calculate its effective properties, basically how it behaves on average. And finally, you use those effective properties to build your big model of the whole thing. It creates a solid mathematical bridge from the micro to the macro. And this brings us to another part of the framework's focus on rigor. A central rule is that there's no such thing as a free lunch, or in this case, free energy. Any model using this code has to mathematically prove that energy is conserved. You have to show that your material is stable and that its surfaces can't just magically create energy from nothing. So let's zoom back out. What's the end game here? What would the world of physics even look like if this framework was actually adopted by everyone? Well, one of the biggest real-world impacts would be a new standard that lets us actually compare different models. Right now, trying to compare two different physics models can be like comparing apples and oranges. The UPT says every model should have to report a set of standard numbers, like the speed a disturbance travels through the system. This would mean for the first time, scientists could put totally different theories head-to-head on a level playing field. So when you boil it all down, the shift they're proposing is massive. It's about moving from all these siloed, separate models to one common language, from an endless sea of custom equations to one master formula, from results you can't compare to standardized reports. It's a move from a bunch of disconnected theories to a single unified framework. The ultimate vision here is just incredibly ambitious. It's to build a single, consistent, and super rigorous common ground for a massive chunk of physics. Basically, anything and everything that involves the relationship between the inside of an object and its surface. And of course, all this leaves us with one heck of a final question. The search for a unified theory has been driving physics for 100 years. The UPT offers not just another potential answer, but a whole new language for even asking the question. But could one framework, one single master recipe, really be enough to describe the sheer, infinite complexity of our physical reality? Now that is something to think about.